In engineering management, we have this saying, you can't manage what you can't measure. But what if measuring something means destroying it? That's the paradox researchers have been trying to solve for concrete. Now, here's a wild thought. What if I told you that scientists have figured out how to predict how strong concrete is without breaking it? And even better, they're using artificial intelligence to do it. Sounds like science fiction, right? Well, stick around because this is very real and it's pretty amazing. So here's the problem. Concrete is literally everywhere. It's the most used construction material on the planet. But here's the catch. Testing it usually means destroying it. You've got to drill into structures or crush test cylinders to figure out if it's strong enough. That's expensive, wasteful, and honestly, not great for the environment since making cement produces a ton of carbon emissions. That's where non-destructive testing comes in. Think of it like giving concrete a health checkup without surgery. Scientists use ultrasonic waves, surface hardness tests, vibration analysis. Basically, they're poking and prodding concrete in gentle ways to figure out what's going on inside. But here's where it gets interesting. Temperature changes everything. If you cure concrete in hot weather, it gets strong fast, but might be weaker in the long run. Cold curing is slow, but creates tougher concrete over time. And this temperature thing? It completely messes with those non-destructive tests. They start giving wonky readings. Researchers at Texas State University decided to tackle this head-on. They made a bunch of concrete samples, cured them at cold, room, and hot temperatures, and tested them at different ages, from 1 day old to 3 months old. They used 4 different testing methods and tracked everything. They tried the old-school approach, basic statistics, and it kind of failed. They only got about 56% accuracy. That's basically a coin flip. The math just couldn't handle how complicated the relationship between temperature, testing methods, and actual strength really is. So they brought in the big guns, artificial intelligence. Specifically, something called an artificial neural network. Think of it as a digital brain that learns patterns from data. At first, even the AI struggled because they didn't have enough data. But then they did something clever. They used a technique that artificially expands the dataset by adding realistic variations. Kind of like training someone not just in perfect conditions, but with all the little imperfections of real life. And boom, the AI nailed it. We're talking about 98% accuracy. That's a massive jump from 56%. What does this actually mean? Well, construction companies can test concrete more accurately with way fewer samples. That means less waste, lower costs, and less carbon emissions from making all that extra cement. Plus, you can assess buildings and bridges without damaging them. Super important for old or historic structures. But the really cool part? This is just the beginning. Imagine sensors in concrete continuously feeding data to AI systems, giving real-time updates on structural health, or AI helping design custom concrete mixes for specific climates and conditions. We're talking about smart concrete that can basically tell us how it's doing. So here's my question for you. As AI gets better at understanding materials and structures, how else could we use this technology to build smarter and more sustainably? What if our buildings could actually talk to us? Drop your thoughts in the comments. I'd love to hear what you think. And if you enjoyed this episode, hit that like button and subscribe to Engisphere so you don't miss our next deep dive into the world of research and development. Until next time, stay curious.